Hello, and thank you for joining us for today's webinar, Cloud Observability 101, Start and End with Performance. Before we dive into today's presentation, I'd like to go over a few housekeeping items. If you have a question at any point during the event, please submit it via the chat window or the Q&A window. We'll address your questions throughout the conversation and at the end of the presentation. Also, the recorded version of today's presentation will be available following the event. Please look for an email from the Kentic team to rewatch and share the presentation. And now, Anil and Dan, I'll turn it over to you.
Thank you, Angela. Hey, everyone. Thank you for taking time out of your busy days to join us today. We usually get some people that have never joined our webinars before, and so we like to do a quick introduction of who we are and what we do. So I'm just going to run through a couple of slides, and then we'll get into the meat of the presentation today. So just to tell you a little bit about ourselves, we've been around for a little over 6 years now. And at this point, we have about 300 plus enterprise customers. And those customers range from, the most common service providers that you may have heard of, to the big SaaS applications that you might use on a daily basis, to, the big e-commerce companies that you've heard of. And so that's some of the logos that you see at the bottom. The kind of services that we provide to our customers are essentially driven by the large amounts of data that we collect from their networks, so trillions of records every day. And we surface up information to these customers that essentially enables them to be able to manage and ensure that their networks perform at the highest level. And that is reflected in the high levels of uptime that our customers experience as a result of using our products. And so, we're extremely proud of the customer satisfaction scores that we get, and make every effort to make sure that those stay the way they are. So to tell you a little bit more about our platform, essentially, there is 3 pieces to our platform. So on the left side here of the slide, what you're looking at is the various sources of network data that our platform ingests. So these might be network elements that are residing on your corporate networks or your edge networks, or they might be, elements inside your cloud instances. So we can ingest VPC flow logs and streaming telemetry, as well as SNMP data. And you can also do synthetic testing and send that data to us. So what Kentik is capable of doing is ingesting, not just ingesting all of this data that comes from your networks, but also gives you the option of then enriching that data with your own business-specific context. So if you have information about the kinds of business decisions that you want to make, and you can frame those in some sort of metrics or data, you can sort of combine it with your network telemetry and send it to us. And by doing that, what you get is essentially the things that you see on the right side of the slide. So basically, we provide you a set of tools that essentially enable you to ask any question that you might have about your networks and be able to get an answer to it. So some of the common things that we provide you are dashboards and queries, as well as various analytics and integrations into your workflows. So the way these things get surfaced within Kentik is through a suite of products, and those are essentially the ones that you see at the bottom there. So they include, basic code networking, monitoring, as well as edge monitoring. We have a product that's specifically tailored towards security needs, and then, of course, service provider analytics. For the demo today, or for the webinar today, we primarily want to focus on 2 of our products. So the first product we'll talk about is the cloud product, and Dan is going to show you how you can utilize data coming from your AWS VPC flow logs within Kentik Cloud, and use that to sort of be able to debug issues reactively when they occur. And then once Dan walks us through that, I'm going to show you a glimpse of our Synthetics product, which is more about proactive monitoring. And specifically, I'll show you how you can proactively monitor performance between your various cloud instances or between your cloud regions and your on-prem data centers. So that's kind of the general overview of our platform, and also a general overview of what we're going to show you today. So with that, before we jump into the actual meat of the presentation, we have a quick poll for you all. And so if you wouldn't mind just taking a couple of minutes to tell us a little bit about how you monitor performance between your cloud instances today, or between your clouds and your data centers. and you should be seeing the poll on your screens now.
Okay, we'll give it a few more seconds. Looks like we're getting some answers. Okay, great. I will go ahead and end the poll, Neil, and I will share the results.
Oh, thank you, Anil. Looks like we got a pretty good mix of responses here. What I figure, so actually, I'm going to next hand things over to Dan to talk us through the cloud portion of our demo today. Take it away, Dan.
All right, thanks, Anil. Let me go ahead and share my screen. All right, can folks see my slides here?
Yes.
Okay, thanks. All right, so as Anil said, Kentic's been around a while, and if you are familiar with Kentic, then you probably know that our origins are really ingesting data sources from on-prem networks. But what might not be so clear is that Kentic's been helping companies operate better in the cloud and move to the cloud since 2018. Today, we support cloud and VPC flow logs and cloud metadata from Amazon, Google, Azure, and IBM. We also support flow logs that are generated from Kubernetes clusters, and we enrich those with kube metadata like cluster names, and pods, and namespaces, and so on. So taken together with our on-prem capabilities, which we're not going to focus on today too much, and the synthetic features that we will definitely touch on later in the call, what that means is that we've got the tools necessary really to help users migrate, secure, troubleshoot, and optimize their clouds. So let's dig into that a little bit. And why do we want to monitor network traffic, to, from, and within the clouds? It was the old saying goes, you really can't manage what you can't monitor. And that still is true today. And in the cloud, there's just certain things that you're just not set up to monitor easily, because as advanced as cloud providers are in terms of the services that they actually offer, flow and performance monitoring is almost always a secondary concern. In my opinion, this really stems from the reality that when we shift resources away from the data centers that we control into the cloud, we are in many ways outsourcing that operational functionality. Just as you don't have to worry about replacing failed drives, the thought is that you really shouldn't have to worry about your latency between zones. And of course, at the surface level, that's all true. None of us really wants to worry about these things, but network performance and failed drives aren't the same. Because when a drive fails, the system's designed so that there's enough redundancy that your users won't see impacts in their read or their write times or their latencies. But when networks fail, it's just not the same level of abstraction. There's almost always an impact. Packets are dropped, network latency or jitter increases, even if it's momentary. And so for many of our applications, this stuff really matters. And so building or migrating workloads into the cloud requires that you sort of trust your cloud provider, to the second point on the slide, that they can maintain a stable environment. And that begs the question, what's considered stable? On cloud networks, even if they're abstracted, they're still subject to the same rules of physical networks. And so that means that the latency, packet loss, and jitter I just mentioned are real concerns for your application stability. And it also begs the question, do you trust that as long as AWS is reporting a green check mark on your services and zones, that everything is as well as you expect, or more precisely, as well as when you deployed your app a week ago? So without a baseline, how do you even compare your performance or visualize the trends? And if you can't recognize trends, how can you hold your cloud provider partners accountable? How can you work with them to resolve problems? How can you describe the problems that you're seeing to them so they can resolve them? And how do you communicate those issues to your internal software and DevOps engineers so that you all can work together to mitigate and resolve issues? And so the last point on the slide, really, the cloud requires us to mix infrastructure. We mix things that we can control with components that we really have no control over. So for example, if you run a single VPC with a few subnets and maybe an internet gateway or two, your infrastructure is very simple, very consolidated. But this is really uncommon. More common for us is to see companies in the cloud that are connected to one or more clouds, a handful of data centers, a handful of routing sites, and one or more office spaces. And so in these cases, performance is super critical to understand what components are failing, what traffic is affected when those components are failing, and what that digital experience really ultimately is for the users that rely on all this infrastructure. So let's talk about how Kentic can help address some of those issues today. Kentic's built a whole series of functionality, and we're continuing to invest every day in shining a light into the cloud to kind of make it less of a black box for you folks. As I mentioned earlier, we support each one of the major clouds, and that makes us a pretty natural fit for any organization that's either hybrid or multi-cloud. And we leverage the strengths of each of these three cloud providers' flow logs to build unique use cases around migration, or performance, or security and troubleshooting. As I mentioned earlier, we of course support on-prem data sources for your data centers and office buildings and VPNs and routing sites. And when you add on that layer of synthetics, we can now fuse all of these data sources together to kind of understand, what is broken and what is impacted. So Kentic gives you these tools to configure synthetic tests, for example, over your direct connect virtual interfaces. And when we see latency or packet losses increased on this link, we can then turn to the traffic and say precisely, what teams, applications, or infrastructure was impacted by that new changing network condition. And traffic logs are valuable on their own. So let's actually jump into a demo now, where we explore how we can use flow logs in the cloud to make sense of an AWS outage. So I'm here in our demo environment, and we've got this fictitious company, Acme Services. And Acme operates a hybrid infrastructure in multiple clouds. They have 2 physical data centers along with branch offices throughout the world. And just a day or so ago, Acme had a minor outage in AWS. It disrupted their operations. And when cloud providers fail, sometimes you don't know the root cause, but you still have to figure out what the impact is so that you can make changes to the parts of the infrastructure that you do control. And like many of you on the call, I'm sure, who have been impacted by similar events, Acme's SRE and DevOps teams reached out to their NetOps teams to help them understand what the impact on their customers was so that they can get back up and running. And this is a really common pattern. The reason is that tools that DevOps teams use to monitor their world, their view of the world, are usually based more around logs, metrics, and traces that describe their applications. And they don't have the tools that look at the big picture of their infrastructure inside their cloud and outside of their cloud, like we're going to do here. So let's go into the Kentic Map. And the Kentic Map is a feature that allows you to really see your entire infrastructure all at once. So just as a means of a tour here, we can see that the cloud providers here that Acme runs their infrastructure in. And then we also see the internet block, which includes the source and destination ASNs, the providers, and the next hop networks that show the traffic that we're flowing to and through. And then on our on-prem network, we can show all of the routing sites and even the data centers and offices that Acme operates. As an aside, we can show the health of these items as well. So we pull SNMP from these, and we can, give you the hints when things are healthy or not healthy, both in the cloud and out of the cloud. We've got the lines that connect the different blocks, so you can get that complete picture of your traffic as it flows through these different components. And then if we have traffic going between these sites, we can even show the traffic flowing internally in the network. Everything on this map is clickable. And so I can go ahead, for example, here and click on Amazon. And right away, we can see this dip in traffic that represents the outage that I'm speaking of. And seeing everything is great, and the map here definitely helps a lot. We can totally dig into things, right here in the map without changing. But I'd like to also show off our data explorer and explain how we can use that to, really dig into the network observability concepts that Anil touched on at the beginning of this call. So the Data Explorer, like I said, was built to enable that kind of network observability. And that means that what that means to us is really having unbounded insights, the ability to ask any question of your data, and allows you to iterate quickly through your data, because Kentic's built on this amazing backend database that can scan, millions and millions of rows per second and provide you with that sort of instant feedback with your data. All right. And so, when we look into this kind of thing and we want to start to assess the impact, we might want to change the query a little bit. And so I'll change the dimensions that we're showing here, and I'll add in a dimension that we call traffic profile. Okay. And so looking at the graph, we can start to see this story unfold a little bit. So prior to the incident that we're talking about, we see the vast majority of our AWS traffic was internal. And then following this, we also see that the cloud to outside profile, meaning traffic that originated inside AWS and went out to the internet, but not including the AWS or the Acme on-prem network, was the second largest traffic profile. But as the incident unfolds, we can see this sharp decrease of traffic between 5 a.m. and 6 a.m., where traffic was just a fraction of what it was previously. And we can also see here that some traffic profiles actually remained unchanged. We can dig into this a little bit better visually if we change our visualization. So let me show you how to do that. I'm going to move this from a stacked area chart to a line chart. And then I'm just going to mute the top few series of data so we can really see this story plain as day. Now, if I've muted the cloud internal, where the vast majority of the traffic was lost, and then I even mute the cloud to outside, we can see very clearly that these, some of these traffic profiles were actually unaffected. In that case, we see the outside to cloud, so traffic coming from the outside and into the cloud, and from the inside, meaning my data center traffic going to my cloud was completely untouched. And so this helps us to begin to draw some conclusions, i.e. some parts of our cloud were, completely unaffected while others were deeply impacted. So what were they? I'm going to use a really neat feature of the Data Explorer to dig in a bit here. So the first thing I'm going to do is scroll to the bottom of this query sidebar. I'm going to choose a new dimension. I'll pick region here because I want to dig into what regions were affected by this outage. So I'm choosing source region. And then at the bottom of this query panel, I'm going to choose this feature that I was mentioning, this generate one chart per series. And so what this feature does is it enumerates each of the values it gets from the main query, in this case region, and builds out an instant dashboard by running a separate query for each region that it finds from that initial dimension. So for this dashboard, I want to choose traffic profile so we can get that same view, but across each region. All right, let's take a look at the graphs. So we can see here that we've got US East 1, where we know the bulk of the bulk majority of our traffic was prior to this incident. And we can also see that most of this traffic was internal. And we see this dip in cloud internal traffic, and we also see an increase in through traffic at that particular time. And below this, we have got our AWS traffic that doesn't represent any region at all. So that you can think of this as the global traffic that AWS runs. Think S3, IAM, CloudFront, server certificates. We can see in this case, a lot of our global traffic actually took a deep dive too. And this is probably because, as we learned back in November, a lot of the services that AWS runs globally are hosted in US East 1. That's just a hypothesis. And below that, we've got our backup region, US East 2. And you can see here, it's quite clear that, across all traffic profiles were completely steady. We had no outages whatsoever. And so that's really telling to us. We have a crisper story. We know which region is affected. We know which regions are stable. But let's go ahead and dig further into what portions of our infrastructure were impacted and what customers were impacted. So scrolling back up to US East 1, I can click on the graph title to refocus our experience around only US East 1. So now let's drill into Cloud Internal and see what infrastructure was actually impacted. And the way I'm going to do that is click on the options menu for this Cloud Internal row and say show by. And I'm just going to type VPC. In this case, I'm going to choose my source and destination VPC ID and show by those selected dimensions. Okay, so we can see here that our first answer is that this is one VPC talking to itself. So this is very much internal traffic. One single VPC is affected. But let's go a little deeper. Let's look at what VMs and applications are speaking. So I'm going to modify the query again and notice that our filters have been automatically updated from when I chose the show by option. I'm just going to modify the dimensions this time. And I'm going to say instance. So I want source instance name. And let's also take a look at the applications that those instances are talking to each other with. I'm going to put the application dimension in the middle. So we kind of got a sandwich there and hit save. All right, so this shows us the instance names and the applications that these instances are talking to each other. And that tells us a bit more to the story. We can see now that this is our Kubernetes cluster nodes talking to each other, mostly via HTTP proxy to other nodes. So, let's go ahead and, change our filter from US East 1 to US East 2. All right, so a little more boring, but we can now verify that we don't have any dips over here. And so we can say with a ton of confidence to our internal DevOps teams or to the cloud, account manager, whomever we're trying to describe this problem to, what the problem is. And then to our internal teams, we can say, hey, let's redeploy our app in US East 2B. We've got, a good VPC over there. We'll be back up in no time. And then we can also use reports here to illustrate this to our people. So I'm going to go back to the US East 1 by just clicking back. And I can go ahead and I could say, let's go ahead and export this view as a PDF. Or if I want to get down to the table, I can export things as a CSV. I can email this report. I can share this view. Or if this is something that I'm going to find myself doing over and over again, I can just add this to a dashboard and have this visualization or any other visualization that I want viewable side by side. And just to kind of cap things off here, if I go back to the Kentic Map here, and let's say that my app team decided that they want to redeploy that app in our on-prem Kubernetes cluster, they can do that as well. And if we drill in here to the site, the SJC1 data center, we can see that if we use the internet intelligence and data center intelligence that Kentic has about this particular site, we can watch that workload pressurize this DC fabric and keep tabs on the switching and the routing health using SNMP and streaming telemetry, which is all baked into the product too. And so we can then explain, how we can see this traffic delivered out to the end customer through the internet block. So I think that's probably it for me. I'm going to send it back over to Anil.
Thank you, Dan. I'm going to go ahead and steal your screen share back. Cool. Do you see my screen now?
Yes.
Thank you. All right, cool. Thank you so much, Dan. So that was an amazing demo. I thought it was really cool that you could go back after the fact and look at things that happened, not just look at things that happened 3 months ago, but also be able to slice and dice it and try to figure out what exactly happened there. So, Dan showed us how you can look at information based on the actual network traffic that is flowing, the actual user traffic, and the actual real traffic that is flowing through, and sort of reactively debug situations that happen and prevent them from happening again. What I'd like to talk about next is how you can sort of proactively monitor things. Oops, right here. So, what I'd like to do next is talk about how you can proactively monitor things. And so the way you can do that, one of the ways you can do that is using our Kentic Synthetic product. And so the idea with Kentic Synthetics is rather than looking at traffic that is flowing through passively, you would generate your own artificial traffic and then measure performance based on that so that you're proactively looking at performance of your network before it impacts your users. So, just to sort of put this in context, we, as we were talking to our customers that are using our synthetic product today, we asked them, hey, so, in cases where you're looking to monitor public cloud connectivity actively, and I use the word actively to differentiate it from looking at network flow traffic, why do you do this? What are the most common reasons why you do this? So, and here's sort of the main things that we heard in those conversations. So the first one is something that I think Dan touched upon as well, which is, these public cloud providers are massive companies. They operate at scale. And they obviously are good at providing a very resilient network. And so it's good to trust them. But at the same time, it's even better to be able to verify that you're getting the kind of quality of service that you get. And that's what you can do with active monitoring. The second thing is that, given the way the world is today and the way the world has kind of been even before where we are today, your employees and definitely your customers are pretty globally distributed. So you might have a SaaS application that's running primarily or that is primarily built in the US, but is getting accessed by people all over the world. And so having a way to know what sort of quality of service somebody sitting in Asia or Africa or New Zealand is getting is really important in this day and age. And then the next couple of things are kind of related to the transition that applications have been going through in the last decade or 2 decades. So applications are no longer monolithic, meaning gone are the days where you had a single Java application that would talk to a database. Now most applications have at least a few instances. And if you're running them in clouds, they're typically deployed, replicated across multiple regions. And then in the very extreme case, if you're sort of like on the very cutting edge of your development, or your development team is on the very cutting edge of what's possible, your development team or your app teams might be running several dozens of microservices that comprise this one single application. And these microservices are typically talking over a network. And so ensuring that there's low latency between these microservices is super critical to the overall performance of the application and ultimately the end user experience. The next thing, which is kind of an up and coming thing, is not as prevalent yet, but is starting to pick up, is the idea of multi-cloud deployments. So, you might choose to not just have all of your apps and services running in one cloud like AWS, but you might choose to leverage a second cloud for some specialized capabilities. One of the common things we hear every now and then is people really like having their data in BigQuery because of all the querying capabilities that provides in Google. But they like to use EC2 for their app instances because they've already deployed there, or because it's just the most common and most amount of tools there. So just being able to ensure that your applications instances that are sitting in EC2 are able to communicate with your data in BigQuery is critical as well. And then the last thing I'll point out is that the things that we're going to talk about today in terms of monitoring connectivity between public cloud regions, these same techniques can just as well be applied to your data center to data center connectivity, or to your data center to cloud, as Dan showed you in the hybrid map case, right? So let's talk a little bit about how you can do this. So the specific product that I'm going to focus on is called Kentic Synthetic. So I won't talk a ton about what Kentic Synthetic is. But essentially, it's our newest product in our suite of products, and essentially it consists of a set of global testing points that we provide out of the box, as well as any testing points that you can set up on your own. And then it's really easy to generate synthetic traffic or artificial traffic from these locations, and be able to measure performance to any other points in the world or within specific networks. Some key things that we do that are very different from other solutions that are out there in the market is that we are able to leverage all the data that we have about real traffic, real flow information, and real SNMP type of data to make it easy for you to be able to set up these tests. So not only will we give you the ability to set up these tests synthetically, but also point you to specific portions of the network that you should be testing. And so that's what we refer to as our autonomous testing capability. So I'll get into this a little bit in the demo, but specifically what I want to focus on today, given that we're talking about cloud, is the feature that we have in our product called Cloud Performance Meshes. And so what these are basically our attempt at providing more value to our customer base by creating a set of tests and making them free to all of our customers. So what you're looking at here is essentially a set of mesh style tests. So these mesh style tests are ones that are running between different regions of a given cloud provider, and then also between different regions of different cloud providers. So there's a multi-cloud use case as well. And so these tests are continuously running every minute, and they're running between different regions. We test bidirectionally, so they're testing from US East 1 to US East 2, and then backwards as well, as an example. And for each of these situations, you can look at the latency, packet loss, and jitter at any given point of time. And then, for all of these cases, you can look at detailed path information, and you can customize it to your own use cases. So without talking a lot more about this, I'm going to go ahead and jump into a demo of how you can utilize these. So here I am back again in our Network Explorer view that Dan started with as well. But rather than spending time in this portion of our product, I'm going to jump into the Synthetics portion of our product. And I'm going to start with agent management. So as I mentioned, Synthetics is all about testing actively. So you're generating traffic and you're measuring performance to a specific location. So as you can see in the map above, we have these global deployments of synthetic agents that we provide you out of the box. So if you're someone that just wants to have something ready to go as you get into a product, that's available to you. So every single point on this map where you have a Kentic logo is what we refer to as a global agent. And we have coverage across various provider networks as well as various public clouds. So specifically talking about public clouds, we have agent deployments in pretty much 5 of the major public clouds. And in addition to utilizing these agents for your testing, you also have the option of deploying your own private agents. So these would be agents that you would install on your own infrastructure. And we provide various options when it comes to that in terms of packages, and it's a really easy install. So you have these agents and you can run tests from them. And so let's go look at the kinds of tests that you can run. You can add different types of tests ranging from network layer tests to web and DNS, and then you can also leverage real flow traffic to look at what are the common destinations where you have the most amount of traffic going, and then choose to monitor one specific one of those. So that's just a general overview of how Kentic Synthetic works. Now, to jump into the specific thing that I want to talk about today, which is monitoring cloud performance. So here is the cloud performance mesh tab that I talked about. And so as I mentioned before, the idea here was, rather than having most customers that have cloud deployments care about monitoring performance between different regions and making sure they know before something bad is happening in these clouds and are able to sort of proactively address it before it impacts their customers. And so we build these cloud meshes that are, testing between regions of the 3 main cloud providers and then between regions of all 3 at once. So let's say you only had deployments in AWS and you didn't care about the other ones. You can go ahead and hide those in your accounts, and it'll only show you the AWS specific cloud mesh here. So what you're looking at here is the different cloud regions here, and traffic synthetic tests being run between those regions. So in this particular instance here, we're testing from, for example, AP Northeast 1 to EU West 3, and then similarly you might have tests running from US West 1 to somewhere in Turkey, and so on and so forth. So the idea with these meshes is to give you a quick overview of how things are looking. The 3 dots here represent the 3 metrics that you care about. There is latency, packet loss, and jitter. So just by looking at this at a high level, you can quickly spot specific, network paths between different regions which might be potentially having issues right now. And when you do notice an issue, you can quickly drill down into that by clicking on View Details, and that will take you to a set of time series charts that will show you any spikes when they occur. So in this case, it's just jitter, so we don't care too much about that. Packet loss and latency look fine. So going back here now, the other thing that you can do from here, so let's say your particular situation is one where you have a little bit of AWS deployments, but it's not everything. And you still have a significant presence in your own data centers. And so, while you care about testing specific regions of AWS, you also care about connectivity to your own data centers or within your data center, right? So if you have that sort of situation, customizing this type of a mesh is really easy to do. So you can go ahead and click on the little customize button that you see here. And what that'll do is now it's taken me to a page where it has created a copy of this, or it's going to create a copy of this test. And it's showing me all the AWS regions and the agents that are part of this test. So let's say I'm a customer that's in the US. And so I don't really care about testing to the regions, AWS regions that are outside the US. And so I don't care about Tokyo, I don't care about Sydney, and I don't care about Paris. But what I do care about is, my 3 or 4 data centers. So in this case, we have the Acme data center. So I'm going to go and pick those 4 locations, and I'm going to hit add to it. And so what's going to happen now is those are going to get added in place of the 4 that I took out, and I can add any number of these as I want. So what it's done now is it's changed the mix to include both public cloud regions as well as my own data centers or data center regions. And then what I can do here is I can now give this a name. So I'm just going to call it AWS hybrid mesh. And just to know what this is, I'm just going to call it webinar. I have the option of choosing specific notification channels here. So I can say you can go and email me every time a test fails. And then I have a whole bunch of options that I can configure here. So I can say, I want to test every minute, every 5 minutes, every second if I want to. I can set thresholds for ping and latency. I can, decide whether I want to be testing using ICMP or TCP, so on and so forth. So when I go ahead and save and start testing with this, it's going to create essentially a mesh that looks similar to the meshes that you saw before, except now it's going to have a mix of AWS regions and your own data centers. So this takes a few minutes to show data. So what I did is I actually created a replica of this ahead of time. And so that's what this is. I'm going to go ahead and click on this one and show you what this information looks like now. So it's going to look very similar to what you saw before with the pure cloud mesh, except now we're testing between regions that include the data centers as well as the AWS regions. So I can hover over one of these, and I can look at testing points between data centers or between cloud and data center here in this case. I can look at all the results in a tabular view here, and I can scroll back in time and see, how this changed over time as well. So that's just a quick overview of, how you can leverage synthetic agents to run proactive tests, not just between cloud regions, but also between cloud regions in your own data centers if you had a hybrid cloud deployment. The one last thing I'll leave you with, there's a ton I can talk about in synthetics, but I know we're sort of going pretty long here. So the one last thing I'll leave you with is Dan showed you how you can sort of you can use the data explorer to create these custom views of your flow data, and you can add them to specific dashboards. So what I'm going to show you now is an example of one of those dashboards. So let's say we have this idea of custom dashboarding in our product where you can go ahead and add any sort of data sources to a single view and make it custom to your specific situation. So in this situation, what you're looking at here in this dashboard is real traffic going between different availability zones of AWS. And then you have, dashboard widgets that are showing you the utilization by server ports, the sources, and then the top talkers and so on and so forth. So what I can do now here is, this is all real flow data. It's not synthetic test data. What I can do is now I can add the synthetic test mesh that I just created into the same context, so that I'm basically going to be able to look at not just the real traffic, but also the synthetic test right alongside it. So to do that, I'm going to go ahead and edit this dashboard. And then I have the options of adding either raw flow or data explorer view, which Dan was showing you how you can customize. But I'm going to go ahead and add the synthetic test that I just created. So I'm going to go ahead and try to find the one that I just created just now. Let's see. So there's the AWS hybrid cloud mesh webinar mesh that I created. And I have the option of displaying either as a table or as a mesh. So I'm going to go ahead and say, show it to me as a mesh. And let me set this to be controlled by the dashboard and add the panel. So now what's going to happen is it's going to add that mesh that I just created a couple of minutes ago to this same dashboard here. And I want to look at this in the context of the Sankey diagram up top that was showing me the traffic. So I'm going to go ahead and try to move this thing up there so it's alongside that thing there. So put this here and then sort of resize this a little bit. So resize, and then so now we have this view here. I'm going to go ahead and hit save. And so what I'm looking at now is I can look at real traffic flowing between different availability zones, and I can also look at synthetic tests running between different regions as an example. So both of those contexts right there. So that's just a glimpse of what you can do with the kind of testing you can do with synthetics. There's a lot more we can talk about, and we'll probably do it in future demos. So coming back to this now. Hopefully what you took away from that little demo there was, using synthetic type testing, not only can you monitor inter and intra-cloud performance between all leading cloud providers, we essentially make that free of charge for all of our users because we know everybody cares about it. The other thing you can do is you can customize these to your own. So if you don't care about just pure cloud performance, you can customize it to your own hybrid cloud networking needs. And then you can test continuously. So you can choose to test every minute, even all the way down to every second. And then you can get down to the root of a cause using path analysis, which actually I forgot to show you. So I'm just going to pop back in here. The other thing we do here is we show you pretty rich path experience that shows you pretty much each of the agents going through various network nodes along the way. This is a really complex one because there's a lot of points in this. But you can choose to just go down to one single portion of these tests. So, in this case, if I was to pick the same mesh again and just pick one single test point within this, as opposed to the whole mesh, and click on its details, I would see just a path view that would show me that particular, Acme server testing to the destination. I can click on this. I can see a full trace over here. I can click on individual points. I can look at what's going on here. I can, break down to the specific ASINs. So just some of the tools that we give you to not just get to the knowing when a certain failure happens within your synthetic tests, but going that extra step and trying to investigate where along the way is that latency or that packet loss getting introduced and getting to the root of it. And then last but not the least, just being able to map synthetic test data with real world traffic in one single unified view. I think has tremendous potential in terms of saving you the time it takes you to get to the root of a problem. So that's kind of the extent of our presentation today. If any of the stuff we showed you today is of interest and has got you excited about wanting to look at our platform, it's super easy to get started. So if you just head over to kentic.com, there is a try Kentic button on the top right of our webpage. If you click that and enter a couple of pieces of information, you'll pretty much get access to every one of the pieces of functionality that we showed you today. So it's going to be a 30-day free trial, and it includes literally everything that you saw in the demo today. With that, we'll go to a few Q&A.
Hey, thank you, Anil and Dan. It's awesome presentations and demos. So we did have a few questions come in. I'll start with the first one. It's, have you tested your solutions in use cases demanding real-time visualization of inter-microservices traffic, meaning applications where north-south L7 and east-west L4 are facing scaling challenges? And then another part of that question is, how do you produce real-time service graphs for L4 and L7 loads related to HTML5 video?
Sure.
Okay.
Wait, Anil, did you say you're taking it or shall I?
Go for it, yeah. It seems like the cloud.
Yeah, cloud question.
All right. So yeah, we have tested our solutions in these specific circumstances. One of the things that we have to be clear about, though, is that with flow data, it's not like packet data, in that we don't distinguish, between payloads, layer 7 traffic versus layer 3 versus layer 4. We can, of course, map application profiles to different flow aspects that we can pull out. So, for example, if your video servers are listening on a certain range of IP addresses on a certain range of ports, then we will know traffic that's coming from those IP addresses on those ports is video traffic, and we can tag that appropriately. Getting a little further into the question, looking at the north-south traffic that's hitting a load balancer, it really all depends, right? Some customers choose to run their load balancers inside their kube clusters, in which case we can definitely get the flow logs of traffic hitting that load balancer. If you're in AWS and using EKS, then their default position is to use the elastic load balancers. And a funny thing about AWS flow logs is that they won't produce flow logs for inbound traffic coming on to the load balancer. And so the way that we work around that is we can see traffic originating from the instances inside the subnets. And so we have a proxy where, I shouldn't say a proxy, we have a way of seeing the north-south traffic by looking at the egress traffic from the load balancers instances to the destination instances. And so that can substitute there. And then for the east-west traffic going between pods, I'm assuming if we're talking microservices, that's really quite easy. In all of the managed Kubernetes services, Google, AWS, and Azure for sure, you can turn on flow logs and see that east-west traffic. And then we've got a small agent that can actually run on those pods, super lightweight, takes no resources, and that gets you all of the metadata that shows the source pod, the source deployment, the source cluster ID, and so on and so forth, so you can get that rich view of how that request is handled internally. So long-winded answer, but I hope it was a thorough enough answer for you.
Awesome. Okay. The next question is probably for Anil. Is synthetics running in customer tenancy? Who is paying for the test?
Yeah. So as you pointed out, you can run your agents either using one of our tests using one of our global agents, or you can install agents in your own customer locations or your own data centers. In those cases, if you're running an agent on your own infrastructure and it's a private agent, typically you'd be paying for the credits consumed by those tests. And typically, if you're running an agent on your own infrastructure, the cost tends to be about half of what it is if you're running using one of our agents.
Okay, great. And then we have a few more, and I think we still have some time. So the next one is, on average, how much CPU/memory do the agents consume on the host machines where they are deployed?
Yeah, so they're super lightweight. Our current agent is written in Rust. It's really lightweight. So, as an example, I have an agent running on the Mac that I'm doing this demo from. And then I'm also running an agent on a little Raspberry Pi device that runs in my house. But in general, it's about 2 gigabytes of RAM and I think a dual core processor. And we have specific requirements as far as memory, CPU, and space go in our knowledge base as well.
Yeah. Okay, great. We have 2 more questions here. The next one is, how often do these real flow data metrics update on the dashboard? Is it a fixed time interval, or can one modify it? Great question. Anil?
Yeah, absolutely. So pretty much all of the charts that you see in our product, they have, the concept of timelines. So you can go back, not just on the current time slice, you can go back last 30 days. And, in terms of data retention, we provide you data retention up to years. So if you wanted to archive the data and analyze it separately outside of our product, you can do that as well. The same exact sort of thing you also see in terms of the queries and the time that you can go back. So you can go back, last 30 days here as well, last month, in fact. So very similar.
Yeah. Okay, and then one last question. Can the logs be saved to, let's say, an S3 bucket? can one replay the logs for future analysis / data point?
You want to take that one, Dan, or?
Sure. Absolutely. So the way that we collect our logs is having you point your logs to one or more buckets, generally one per region, or sometimes people choose to centralize that into a security account. And yeah, once we've pulled those logs, we ingest them into our database, and then we keep that stored for as long of a retention time as you'd like. Typically 30 days, 60 days, 90 days, but can go longer. And yeah, we can definitely go back in time. And so, for instance, I raised the point of the Amazon outage that happened over Thanksgiving. We could have chosen to go back to that particular outage and view that.
Okay, great. That was our last question.
Cool.
Wonderful.
Awesome. Great. Thank you so much for those questions. So before we close off, we just have a quick poll again, and the whole intention here is we use this data to sort of craft the next set of webinars and make sure they're helpful to you. If you wouldn't mind taking a couple of minutes, just answer those questions.
Yeah, and we'll just let this run and we can. Perfect. Thank you. We appreciate your feedback. Okay, Anil, I think we can move on.
Cool. Thank you. All right. Yeah. So again, just a reminder that you can sign up and look at any of the stuff we showed today on our website. And if you're interested in learning more, the best way to reach us is at webinars@kentik.com, and we'll make sure we get the question that you might ask to the specific person, whether it's Dan or myself, or it is somebody on our engineering team or our customer success team. We'll make sure we get the questions answered for you.
Yes, and then someone just asked if there's going to be a recorded version of today's presentation, and we will have that. Just look for an email from the Kentic team to rewatch and share the presentation. We will be sending that out to everybody who registered and attended. And like Anil said, if you have any additional questions, feel free to contact us at webinars@kentik.com, and we'll get you to the right person. So, yeah, thank you, Anil and Dan. Awesome presentation. And have a nice day, everybody. Thank you for joining us.
Thanks, everybody.